Welcome to AI Frontiers. Today we explore 17 groundbreaking papers from October 4, 2025 that are reshaping machine learning. From algorithms predicting stock movements through emotional analysis to systems learning coordination like ant colonies, these discoveries challenge our fundamental assumptions about artificial intelligence. Imagine discovering that making artificial intelligence more explainable might actually make it less useful. This interpretability paradox represents one of the most shocking findings from our research collection. While decades of AI ethics have pushed for transparency, new evidence suggests more interpretable models often perform significantly worse than their black box counterparts. This revelation challenges everything we thought we knew about responsible AI development. Meanwhile, researchers are finding that simple data pre-processing techniques consistently outperform the most sophisticated algorithmic approaches, forcing us to reconsider where we invest our optimization efforts. October 4, 2025 stands as a remarkable day in machine learning history. 17 papers spanning diverse domains were published simultaneously, creating an unprecedented snapshot of the field's current trajectory. These contributions range from emotion-driven stock market prediction systems to bio-inspired coordination algorithms that mimic ant colony behavior. Each paper addresses critical challenges in fairness, interpretability, and system reliability. Together, they form a comprehensive map of where artificial intelligence is heading and the fundamental assumptions researchers are actively questioning. The machine learning research ecosystem resembles a vast rainforest where different algorithmic species coexist and evolve. Various methodologies adapt through cross-pollination of ideas, while new applications continuously spawn fresh research directions. This environment maintains a delicate balance between competition and collaboration, where individual breakthroughs contribute to our collective understanding of intelligence. Each published paper represents both an independent discovery and a building block for future innovations. The interconnected nature of these contributions creates emergent properties that exceed the sum of individual parts. Our first major theme focuses on fairness and bias mitigation in artificial intelligence systems. Multiple papers tackle algorithmic bias through novel approaches to fair representation learning. Think of this challenge like adjusting scales to ensure equal justice. Technical solutions must address deep social implications. Researchers are moving beyond one-size-fits-all fairness metrics toward context-specific approaches that recognize the complexity of equity in different domains. These advances represent crucial steps toward building AI systems that serve all users fairly, regardless of demographic characteristics or background circumstances. The second theme explores the fundamental tension between interpretability and performance in machine learning systems. Explainable AI initiatives consistently encounter performance challenges, as transparent models often underperform compared to black box alternatives. This dilemma resembles choosing between a clear paper map and a GPS navigation system. One offers understanding while the other provides superior results. However, innovative new methods are beginning to bridge this gap by developing hybrid approaches. These solutions rethink what interpretability truly means and how we can achieve transparency without sacrificing effectiveness. Our third theme examines coordination and multi-agent learning systems, where artificial intelligence components work together like biological colonies. Ant-inspired coordination algorithms demonstrate how complex collective behaviors emerge from simple individual rules. These systems resemble orchestra musicians finding harmony without a central conductor, achieving synchronized performance through distributed intelligence. The applications span robotics, optimization, and distributed computing, where emergent behaviors solve problems that would be intractable for individual agents. This research opens new possibilities for scalable AI systems that leverage collective intelligence. The key findings from these 17 papers tell many stories of scientific discovery that challenge conventional wisdom. Simple data pre-processing techniques consistently outperform complex algorithmic modifications, suggesting we may be overcomplicating solutions. Emotional analysis of social media content proves surprisingly effective at predicting market movements, revealing hidden connections between sentiment and financial behavior. Interpretable models sacrifice accuracy for clarity, forcing difficult trade-offs between transparency and performance. Coordination emerges naturally in multi-agent systems without central control, demonstrating the power of distributed intelligence. Finally, effective fairness requires context-specific solutions rather than universal approaches. Among these 17 contributions, one paper stands out as our featured breakthrough in fair machine learning. This research addresses critical challenges in algorithmic bias through innovative methodological approaches that have significant practical implications for real-world AI deployment. The work represents a paradigm shift in how we think about fairness, moving beyond traditional metrics toward more nuanced understanding of equity in artificial intelligence systems. The paper's novel approach successfully bridges the gap between theoretical fairness concepts and practical implementation requirements. The methodology section reveals the paper's technical innovation combined with social responsibility. The authors introduce context-aware fairness metrics that adapt to specific application domains and user populations. Their adaptive bias correction algorithms dynamically adjust model behavior based on detected disparities in outcomes. The multi-stakeholder optimization framework balances competing interests while preserving overall model performance. Crucially, this approach maintains accuracy while ensuring equitable treatment across different groups. The solution scales effectively to diverse application domains, making it practical for widespread adoption. The impact and implications of this breakthrough paper extend far beyond academic circles, actively reshaping how we build responsible AI systems. The research demonstrates that achieving fairness without significant performance loss is not only possible but practical with the right methodological approach. It provides a comprehensive toolkit that practitioners can immediately implement in their systems. The work influences ongoing policy and regulation discussions by showing technical feasibility of fair AI. Additionally, it opens entirely new research directions for future investigations, while setting a new standard for ethical AI development across the industry. Looking toward future directions, these 17 papers plant seeds in fertile research soil that will grow into tomorrow's breakthroughs. Integration of fairness and interpretability represents a critical next step, combining transparency with equity in unified frameworks. Scalable multi-agent coordination systems will enable larger, more complex collective intelligence applications. Real-time bias detection and correction will make AI systems more responsive to emerging fairness concerns. Cross-domain knowledge transfer will allow insights from one field to benefit others. Finally, human-AI collaboration frameworks will optimize the partnership between artificial and human intelligence. In conclusion, October 4, 2025, represents a day that fundamentally changed artificial intelligence research. These 17 papers collectively demonstrate that fairness and performance can coexist when approached with sophisticated methodological frameworks. Simple solutions often outperform unnecessary complexity, reminding us that elegance frequently trumps elaborate engineering. Coordination emerges naturally from collective intelligence without requiring centralized control systems. Interpretability demands nuanced approaches that consider contexts and application requirements. Most importantly, the future of AI is becoming more responsible, ethical, and aligned with human values through continued research innovation. This presentation was created through a comprehensive AI synthesis and review process to ensure accuracy and accessibility. The content synthesis utilized Claude Sonnet 420-250514 for analyzing and organizing the research papers. Text-to-speech synthesis is powered by DeepGram's advanced voice generation technology. Image generation leveraged OpenAI's latest visual AI capabilities for creating accompanying graphics. All content underwent human expert review and validation to maintain scientific rigor. Complete references for all 17 papers are provided for independent verification and further exploration of the research topics discussed. Thank you for joining us on AI Frontiers as we explored these 17 groundbreaking papers from October 4, 2025. Subscribe to our channel for daily updates on the latest machine learning discoveries and expert analysis of cutting-edge research. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprintserver.org.